Every chemical that has electrons will exhibit London dispersion forces. Remember that electrons are constantly moving, not only the bonding electrons, but all the electrons in every atom in a molecule. At any given time or instant, there is likely to be a higher concentration of electrons in a particular location in a molecule. This will cause a slight negative charge at that location, which will also cause a slight positive charge in another location of the molecule, causing a temporary dipole or separation of charge. This short-lived dipole can induce the formation of a dipole or separation of charge in a nearby molecule. Here's a graphic of a diatomic molecule between two atoms of the same element. Since these two atoms have the same electronegativity, electrons are equally shared, and it is a nonpolar molecule. However, when there happens to be a high concentration of electrons in one location of the molecule, a partial negative charge forms, as well as a partial positive charge, and a dipole is formed. The electrons of a nearby molecule will be attracted to the partial positive end of that dipole and then form its own dipole. These two molecules will be attracted to one another due to the formation of these temporary dipoles or separation of charge. The greater the number of electrons in a molecule, the stronger the London dispersion force. Thus, the greater the molecular weight, the stronger this force, since higher molecular weight means more electrons. London dispersion force is the weakest of the intermolecular forces, but when there are many electrons, or the molecular weight is high, the force is strong enough to cause molecules to be in the liquid or solid state. London dispersion forces are the only intermolecular forces that nonpolar molecules exhibit. Many low molecular weight nonpolar molecules like nitrogen, oxygen, fluorine, and carbon dioxide are gases at room temperature because London dispersion is the only intermolecular force they experience.